Morning students, welcome back. Today we'll discuss Biot savart law. Okay, from chapter 4th, magnetic effect of electric current. So let's start students. First of all, I will give you information about Biot savart law. Look at students, where is it applicable? Suppose we are having a wire and current is flowing in a wire like this. Okay, and we'll take the partial length. This is the partial length of a wire dl, and whenever the current flows in partial length of the wire, then it produces magnetic field. Okay, and suppose this distance is r, the distance of p point where we have to find magnetic field from partial length is r, and theta is the angle between partial length and distance. Okay, so whenever the current flows in partial length of the wire, it produces magnetic field, and this magnetic field depends on some factors. Before that, I want to tell you the direction of magnetic field. By right hand thumb rule, suppose if current is moving like that, okay, and we know what is right hand thumb rule. When the thumb shows the direction of current, the direction of fingers always represent the direction of magnetic field. According to this right hand thumb rule, thumb showing the direction of current, it means magnetic field will be what? Upwards, outwards. For outward, we'll use the dot sign. Okay, dot means magnetic field perpendicular to the plane outward. And suppose if current is moving like this, so according to right hand thumb rule, if this is the direction of current, this finger will show the direction of magnetic field. It means that will be what? Inwards. So for inwards, we can use cross. We can represent magnetic field by two ways, dot or cross. Dot means magnetic field perpendicular upwards, and cross means magnetic field perpendicular downwards. Okay, so look at the current is flowing in this like in wire. Okay, so if this is the direction of current, okay, this will be the direction of magnetic field inwards. That's why we'll use here cross sign. Cross means magnetic field perpendicular downwards. So we found direction also. So simple students, this magnetic field depends on four components. The very first component, this magnetic field directly proportional to the amount of current. When you provide more current, it produces more magnetic field. On increasing one factor, other factor will also increase. Secondary, this magnetic field directly proportional to the length of the element, its partial length. If we take more element, if we take partial length, when we take the length of the partial length more, it produces more magnetic field. When it is small, element is small, then produce less magnetic field. It is observed by the experiment. Okay, it is found by the experiment, that is a practical topic. And next thing is magnetic field is directly proportional to the sine theta, where theta is the angle between partial length and distance. Okay, and finally this magnetic field inversely proportional to the square of the distance. On increasing one factor, other factor will decrease. So this is observed, this is found by the experiment, okay, by savart, that when the current flows in the partial length of a wire in element, it produces magnetic field at a certain distance r, and this magnetic field depends on these four components. When we combine all these from equation first, second, and third and fourth, what we'll get? We'll get dB proportional IDL sine theta by r square. Okay, and look students, whenever we remove this proportional sign, we always use equivalent constant. Here I am going to use a constant k IDL sine theta by r square, equation 5. Now students, where k is constant and k having the value mu naught upon 4 pi either 10 raised to power minus 7 Weber per ampere into meter. Either one more unit we can take, Tesla into meter upon ampere. Tesla into meter upon ampere. Okay, students. Actually, Weber is the unit of magnetic flux and Tesla is the unit of magnetic field. So this is in the form of flux and that is formed in magnetic field. Now students, K is constant having the value mu naught upon 4 pi and mu naught is a constant. It is called permeability of free space. Permeability of free space. That is constant for magnetic field. That is said to be permeability of free space. Okay. If you want to find the value of mu naught, we can find as 4 pi into 10 to the power minus 7 Weber per ampere into meter. So this is the mathematical form of Biot-Savart law. It is stated that when you flow current in a wire, it produces magnetic field and that magnetic field depends on certain components. It is directly proportional to the amount of current. On increasing current, magnetic field will also increase. It is directly proportional to the length of the element. Okay. It is directly proportional to the sin theta, where theta is angle between partial element, okay, and the distance. And it is magnetic field inversely proportional to the square of the distance. When we combine, we'll get dB proportional ideal sin theta by r square. Whenever we remove proportional sign, we always use equal and constant. K is constant. Remember the value that we'll use in numerical. 4 pi into 10 to the power minus 7. 4 pi upon K equals to mu naught upon 4 pi. Either 10 to the power minus 7 Weber per ampere into meter. Okay, students. Now, I'm going to remove this part. You can take a screenshot. Okay. You can write this. Now, see. Look at students. We'll just extend this form. dV equals to, first of all, I'm going to put the value of K. What is the value of K? Mu naught upon 4 pi. So, mu naught upon 4 pi ideal sin theta by r square. Can we write this equation like this? Mu naught upon 4 pi I dl r sin theta by r cube. Actually, what I did, I multiply and divide by r. On multiplying with same number, it will not affect the equation. Multiply and divide by r. So with dl there comes r and r square and r, that become r cube. Why we did so? Because we want to get its vector form. This is mu naught I upon 4 pi. Okay. Mu naught I upon 4 pi. Whenever we remove sign, there comes cross. Vector dl, vector r upon r cube. This is the vector form of Biot-Savart law. Okay, we did that. This is a simple form. Equation 5 is representing the simple form of Biot-Savart law. We got also the vector form. You know the property A cross B is always written as AB sin theta. When you remove cross, there always comes sin theta. That is called vector of cross product. Okay, that is a topic of 11th class chapter vector. Now students, so when we remove sign, there comes cross and vector sign. So this is the this is the vector form of Biot-Savart law, and that is a simple form of Biot-Savart law. In next lecture, we will discuss its application. There are 3 applications of Biot-Savart law. The first application is find the magnetic field at the center of current carrying coil. The second application is one of the most important for board's point of view. That is, find the magnetic field on x-axis due to current carrying circular coil, and final is find the magnetic field due to long straight current carrying conductor. So we are having 3 applications of Biot-Savart law that we discuss in next lecture. Okay, students.